Hello, this is my English speaking practice and I'm working on coding problems, and today's problem is this binary search tree iterator. Okay, implement the BST iterator class that represents an iterator over the in-order traversal of a binary search tree BST. BST iterator tree node root initializes an object and of the BST iterator class. The root of the BST is given as part of the constructor. The pointer should be initialized to a non-existent number smaller than any element in the BST. Boolean has next function returns true if there exists a number in traversal to the right of the pointer, otherwise return false. Int next function moves the pointer to the right, then returns a number at the pointer. Notice that by initializing the pointer to a non-existent smallest number, the first call to next will return the smallest element in the BST. You may assume that next function calls will always be valid, that is, there will be at least a next number in the in-order traversal when next function is called. Okay, so the input is like this: BST iterator that initialize the BST class, BST instance, and next has next has next, and what is this? I think this is the root node. So the output is like this, and the element should correspond to the input operations. So the input is BST iterator that returns null, and the next function returns the pointer. So that means the tree is like this, so the next is 3 because this is in order traversal. Yep, so 7 3, and the next would be the 7, and has the next check if there is next values, and next value would be 9. So yeah, has next. Yeah, and the next function returns 9, and has next is true because there is next element, and the next returns 15, and still has next function returns true because there is 20. So the next function returns 20, and finally has next function return false because there is no element. Yeah, this is an explanation. So we can initialize BST iterator like this, and the instance can call the next and has next functions like this, and the constraints, the number of nodes in the tree is the range from 1 to 10 power 5, and the node value is from 0 to 10 power 6, and at the most 10 power 5 calls will be made to has next and next. Okay, and there is follow-up question: could you implement next and has next function to return in average constant time and use OH memory, where H is the height of the tree? Got it. the tree node is like this. They have a value and left pointer and right pointer. Yep. And when we basically let me explain. How to implement this before starting to code. So basically the BST iterator class should have a pointer to point the current node, because the function next and has a next function, so we can focus on the current node and its next node. So and we are given the tree node, and the tree is already constructed because the init function takes the root node. So what we should have is the pointer to point the node of tree, so we can initialize the pointer called cursor, and that is none at first, and when the init function called, the cursor would point to the root node. Okay, and I think right now let me think about next function, and has next and next are almost the same, so let's think it together. Since the problem requires us to in order traversal, so traverse in order, so the so in order traversal, that means as long as the current node have left child, we go for left. Okay, so that means as the next means check if there is left child. Okay. But also we have to think about after checking left child, because in this case the in order traverse is like this. So so there are two times when the cursor point to n1, because when it's initialized, the cursor should point to the root node n1, and then the cursor move forward to left child, and left child doesn't children at all, so the cursor going back and it point to n1. Okay, and after checking the left child, the current node should be pointed. So yeah, the next function returns n1, and then after checking left children and the node itself, we can move on to the right child. Okay. So check if is left child, and also we have to check if there is left child when we haven't finished checking left child. Okay. And after finished checking left child, the cursor should point current node. When we haven't finished checking left child, check if there is left child. After we finished checking left child, the cursor should point current node. And yep. And cursor should point to current node. This is has next. So always return true. Yeah, because there must be parent. So in this case, the cursor point left child and yeah, the cursor point left child of n1. Oh wait, I'm confused. So there is several patterns. Check if left child and check if right child. Yeah, basically check if there are children. Yep. And even if oh wait, what's next? Yeah, I see. So it we have to use stack to keep track of the parent element, because when we do look at this node and the cursor point to the n1 at first, and we are going to left node, okay? So when we point the n2 for the first time, it have to check if the left child, so the pointer should point n4, and then since n4 doesn't have any children, so that should backtrack to n2, and the cursor should point to n2, okay? And at the time, the cursor should know that the left subtree is already explored, so finish exploring. So the next is cursor, okay? So the next function should return the node that is pointed by cursor, and after that we update the cursor, so that cursor point to the next node in traversal order in order traversal. So we update the cursor here, and the cursor must point to the next node, so it means it means the cursor point some node. The cursor doesn't point to none. Okay, it means has next. This that BST iterator has next. Okay, that's all. So the key is how can we implement this logic, and there is a follow-up question, and the next end has next to run in average or constant time, and we can use OH memory, where h is the height of the tree. Okay, I see. So we have to update the cursor in constant time, but we can use the list. So basically, the flag is necessary because we have to know if the left subtree is explored or not. So I wanna use flag representing that the exploring is finished or not. I don't think I don't think the flag is not necessary, because in order traversal we are continue to go to the leftmost, so we don't stop for the left child direction, so we don't need to keep track of the flag, because we always finished to exploring for left child directions. That means when we initialize the BST iterator, the cursor is initialized at the root, but it's not correct because 7 is not the first element. We have to return next like this. So in this case, the first next function returns 3 because that is the leftmost node. Okay, so when we initialize the this BSD iterator, we are going for leftmost while cursor exists and also cursor left exists. The cursor is set to the cursor left, yeah, that is left child. Okay, and yeah, the current cursor must be the leftmost child, and yep, and we have to back to the parent node. So in order to do that, we have to prepare the array to keep track of the path. That means when the cursor point Yep. So every time the cursor is updated, we append it to the path because it would be a exploring path. Okay. And when updating the cursor, let me see. There is two options. There's two options. Going back to the parent node or going to going to leftmost node of right subtree. Okay. And how can we branch these two? How can we switch? How can we decide these two branches? Going back to the parent node. So let me see. Maybe we have to prepare some flags, because when the pointer points to the right child, pass next and next pointer would be if there is no children, it should be if there is no children, oh wait, the self cursor means points leftmost right now, and there is no children. We have to, oh wait, current node can be obtained by like this, popping from the path, right? And we can get the parent node from the path, so the cursor point to the parent node. And this time we don't need to append the path because we already added. So yeah, the cursor point to the node where point to the node which is located at the last index of the path. Okay, and else if if the cursor have a right child, we are going to leftmost node of the right subtree, so that means we are going to the right child and additionally we are going for leftmost and append the path. Yep. So that means when we initialize the BST iterator, the pointer, the cursor point to N4 and the path like N1, N2, N4, right? And the next function returns N4 at first, and at the same time we update the cursor for next, yeah, and update the cursor. We pop the current node from the path, so N4 is popped. Oh wait, but that's not good because we still have to go for the deeper, because if there is a right child, we are going to right child once and append path. So in this case we can go to N9 and the path is like N1, N2, N4, N9, and as long as they have left child going for left child, but in this case there is no left child, so the next function returns N9. That is correct. Yep. And at the same time we update going back to the parent node. I see. So this is not good, because when we look after we look at N9, the next pointer must point to N2 because we already N4. So how can we handle this? Maybe we can keep track of parent node to visit. We prepare path, so let me think about this case. For the first time, the path is n1, n2, n4, and the cursor point to n4, and at the same time we have to update the cursor for next, and we pop it from the path because n4 is already visited, so we can remove it. So the pop worked, and there is right children, so we have to append it. But in this case there is no more children, so the path is like n1, n2, n9. Okay, it's a little bit weird, but I think it's fine, it's no problem. And the cursor point to n9, and then the next function called again, return n9 and pop it. n9 is popped, and there is if there is no children, we are going back to the parent node, so we have to use path. Okay, and that is n2. So I think this works. Okay, and for next n2 is returned and path pop, so n2 is popped from path, and they have no children. No, they have children. Oh, we cannot handle it. Children and not children. How about I believe I can make it simpler. What we do is to implement next function, and next function, the cursor always point to the next, so we don't think about has next function, because as next function just return like this. So the next function is like this, so, and we have to we have to think about this case. Left hand. Oh, I see. We can remove this function because because there is no occasion to check if it can be able to go for left child, because we are always going to leftmost. So going to the leftmost, so we don't have to check it because we will because we always going to leftmost, so we don't have occasion to check if we can go for left or not. We should finish going for left child, so we just check for right child. Okay, so if we cannot go to the right, it will go back to the parent node, and if we can go for right, we have to go to the leftmost node of the right subtree. We will always go to leftmost. Okay, so the backtrack is like this. And N2 and N1 is good. And when we look at N1, the next is, so the path is gonna be empty. We pop the N1 from path, and there is right child, so we are going to right child. And there is no left node, so the cursor point to N3, so we can return N3 as the next pointer. And when we look at N3, the next function will never called because the problem assures next function calls will always to be valid. But has next function can be called, but it's okay because the cursor is wait okay, so wait when the cursor point to N3 at the same time. At the same time, we are gonna update the cursor, but there is no next node, so there is no right child, so it reach here, but the path must be empty, so if so it means there is no parent node, so we cannot go anywhere, so the cursor must point none, and that express there is no next node. Otherwise we can go back to the parent node, so the cursor must point to that node. Okay. Okay, let me code it, let me run it. Self is not defined. Oh, I don't know the Python grammar. What is it? It's not a valid value for the expected return type integer. Oh, I see. Wrong answer. Really? What's the next shoot? Why? Really? And I think this is the current node, so maybe we can like this. Yeah, and why? This return 20 and the cursor right must be none, and path Right is none. Okay. Path is not empty. Really? Limited path. Oh. I forget to use self. How about this? Storing what? What? No attribute right. Self cursor. What? What is it? I think self cursor. What? What is it? I see. The path is maybe, yeah, path contains a program path. So at this line, the cursor is updated to string like this. So that causes a problem. Okay, nice. So like this. Okay, let me see the edge cases, some edge cases. When the root is none, the cursor is none, so it's good. Okay. Maybe. Let me see the result. Okay, good. And I just use, yeah, the time complexity. We have to time complexity is pop is constant, and just update the cursor so it's constant. How about this? This takes log n I'm not sure, but I believe it's inevitable because we have to go for leftmost. Oh, I see. So when the BST iterator is initialized, we can calculate the result, and exactly. So just in this function, just walk through the tree in order traversal, just traverse in order, and store the result to list. So for these functions, just update the index and it can refer to the result. That makes sense. So there is a difference between this one and this one. Yeah. So this code, this next function may be O of log n or h, where h is the height of the tree. Yeah. And the space complexity is also O of h. H is the height of the tree because we keep track of the path, exploring path. Okay, that's it. Yeah, it took a long time, but I feel like my explanation is improving. Okay, let me try one more question. Yeah, largest number. Okay, given a list of non-negative integers nums, arrange them such that they form the largest number and return it. Since the result may be very large, so you need to return a string instead of an integer. Okay, makes sense. Yeah. So let's take a look at example 1. We are given 10 and 2, and in order to return a maximum value, the 2 should be first because 2 is greater than 1, so we can make 200. So the answer is 210. And example 2, we are given 3, 30, 34, 5, 9. 9 is the 9 must be the first because we should compare the leftmost digit. So we can sort it, and 9, 5, and 3. There are 3 3s. So in that case, we should compare the second digit, but in this case, we have to choose 34. But if it's 32, the 2 is less than 3, so we shouldn't use 32 because 32 is less than 33. So in this case, we can in that case we can make 332. 33230 would be the answer. So basically we make the sorting algorithm, but it's dependent each other. So let me think about the case. I want to think about these three cases. 3, 3, 3. So the blank means the next number can be the first digit of the remaining numbers. So yeah. How about this? Okay, but when we think about these three numbers, that means the numbers more than 3 is already used. So the blank can be 3 or less, right? Yeah. For example, this case, the 9 and 5 is already used, and if there is 4, the 4 is already used, and there are 3 threes, so we can use 3, 2, or 1, or 0, but 0 is basically not be, cannot be here. And so when we look, so the problem is how to sort it, how to sort them when the digit is same. When the digit is same, we have to look at the next digit. So the 3 can take remaining number, one of the remaining number. So 3 3 3 0 and 3 4. Yeah, 3 4 must be first, and 3 and 30. The 3 can take 30, so that can make 33. So 3 is gonna be first and 30 follows. And this case, we have to think about 3 numbers, and yeah, we can do the same for this. Take it and compare with it. So in this case, 3 can take 30 or 32, so can make 332. 332 is the largest number. So yeah, the main logic is like this, but yeah, I'm trying to figure out how to implement this. Okay. I see. So first of all, can I use the built-in sort function? And we can specify the key that must be the first digit number. So in this case, 33359. So it takes X and the we need to convert it into string and take the first digit and convert it integer and reversed to. Let me print it. Reversed is not invalid keyword. Reversed. Reverse is true. Got it. Yes, great. And the problem is these values, and they depend on each others, so we cannot sort them like this. So right now we're gonna loop it and iterate through the numbers and find the numbers that has same first digit, right? So we can get like this, and we're gonna find these numbers, so we will use double pointer to identify the range. So the L point to the left one and the R point to the right one. Yeah. And between them we have to find the number that should comes first. Okay, so in this case the condition is the second digit is greater than 3, or second digit is 3, or digit is blank, and the last one is this. So we have to sort it based on this. And also the number could be long, could be a long number, so it's not enough to check only second digit. And I think sorting this part can be double loop. Yeah. I think we cannot use built-in sort function, and also we cannot use merge sort or something like that, because this sorting algorithm the numbers depend on the others, so so basically we have to find one by one, so we have to find the largest number between them and write to this, and then increment the pointer and check that. So the problem is, how can we the largest number between them? It's simple, because to find the largest second digit, and if there are multiple, if they are the same, if they have same digit number, same second digit number, we just move on to the next digit. Okay, so we are going to the end of the digit. If they are all the same, either is fine, and if the other becomes blank, the blank can be handled as the number of the first digit. Okay, so yeah, that's the algorithm. So So the strategy is just check one by one and find the largest number. Yeah, and based on the digit. Okay, so let me write pseudocode find maximum. Start to end. Okay. Yeah. It initializes the current max with number at start, and it start with start plus 1 and I in range start plus 1 and end plus 1. The end involves the number. Yeah, end is inclusive range, so we add plus 1. We add 1. And we are going for loop. We want to implement one more helper function. It called compare. Yeah, this function is the name is larger, and it takes A and B. Okay, and if A is larger than B, this function returns true, otherwise false. And the first digit must be the same, so oh wait, I think taking input as string is a good idea because we return string finally. So at this point it can be converted to string, and yeah, thanks to this we can get the digit easily. So the base would be the first digit. Let me first digit, and we are going to iterate through all digits. So we have to find the length max length because we have to consider blank, so we are go for I in range from 1, that means second digit, and to n. And this is converted, but we can compare it directly, I think. So I the digit at I is like this. Okay, and if it's same, continue, and if it's not the same, we can return it, and that expect A is larger than B. Okay, yeah, and if they are all same, we just return true or false. Yeah, and true or false, whatever, and is larger. We can use is larger function. So find the max. Find the max or sort. Yeah. Sort it. Just sort, and okay. Ideally, I have to explain it before implementing, but it's difficult. But I try to explain what I'm going to implement. Yeah, so we already have like this, so we are going to iterate through numbers. We will use two pointer because we have to find numbers that have same first digit like this, and we can identify the start index and end index, and we pass those indices to the sort function, and this function sort the numbers. Yeah, sort the numbers that have same first digit. Okay. Oh wait, I forget to implement process handling when the character is blank. Oh, maybe. So if I will do it later. Let me explain the code first. So this function sorts numbers that has same first digit. So every time we find some numbers that have same digit, we call the sort function, and this function can update the numbers. Yeah, numbers. Okay, so I think I can handle it as a string from the first from the start. So that means nums can be updated like str nums, and we convert all elements into string, and so the nums is list of strings, so we don't need to convert here. We just access the first digit like this, and we sort it, and we get a list of strings like this. And after that, we are going iterate through nums and find the index, start and index. That points numbers that have same first digit, and call sort function to sort them. Partially, and yeah, that's it. Iterate through. Yeah. Every time we find those index, call sort function to sort them partially. Yeah, that's it. and yeah, and implement sort function here. It basically modify in place the nums. Okay, so it takes start and end index, and it start with the current max. It initialize current max with number at the start, and going to look at remaining numbers. And yeah, what we do here is update the current max. Okay, so if is larger nums I current max, the current max is nums I. Okay, oh wait, we have to swap it. So swap it. And it must be double loop because yeah, fixed index is start, and current max is initialized like this, and the number should be compared with remaining numbers, so the it should be s. It starts with s plus 1 and until end, and if it's larger we can update the current max. Okay, that's it. This is a sort function, and let me update the larger function. We have to handle the case where the I is out of index. So so if I is a valid index as A, we can use it, and otherwise we just use first digit. Yeah, because when its number is blank, oh wait, this is not correct. Oh, I find the pattern. For example, three, and and when we compare 3 and 3, for example, like this, but this function just take two values into consideration, but when we think about using this 3, the following number can be 30, or 30, so this value is not good. This is less than 332. Okay, so I mean this function doesn't work, so I cannot find the current max number like this. Maybe I have to find the structure or something like 30. think just comparing based on this, so let me implement the sorting function for key. And value would be 1 billion. So fill 9 digit with first digit. That means in this case the 3 must be first, must come first, because 3 3 3 is 2. It's largest. 3 3 2 3 3 3 3 is not good. 3 3 3 2 3 3 3. It means so. Thanks to this, we can sort. Yeah. So basically, just implement this. And we pass this function to key, and let me long answer. Why? Three must be larger than 3033333. Let me see the X. Can I see that? Oh, doesn't work. Returns new string. Correct. Let me try test cases. Long answer. Exactly. So in this case, there is two patterns. Four three two 432 43 432 432 43 432 43 432 432 43 432 43. Okay. So should I do brute force solution? It's not always to use first digit because it depends on other numbers, so let's go back to the original. At first we sort it by the first digit. That's good. It's like this. And for the numbers that have the same first digit, we have to think about combinations. Basically, we can sort them like this, but it can have the blank as a second or third or the remaining digits. So yeah, so the problem is how to try to check the largest number by concatenating them. And iterate through nums and find the start and index. Yep. So we have to find the start and end index that point numbers that have the same first digit. So as long as the first digits are the same, we have to going for move the right pointer forward, and yeah, so the after that j would be the out of the range. Sort partially function takes I and j, and after that the I should j. Okay, that makes sense. So what we're gonna do is define sort partially function. It takes start and end, and the end is not inclusive. Note that. And yeah. Yeah, the challenge is how to sort it. For example, when we look at numbers that have the same first digit, not first, same prefix digits, same digit prefix, same prefix digits, same prefix. When we look at the same prefix, the numbers made by concatenating other number is depending on the other numbers. So but there must be a logic to find the concatenating numbers, because it must be larger one. When we look at this and this, The number can choose. The number can choose other number. Can choose other number, except for itself. Okay, so that is basic strategy. Yep. Yeah, we are going to update one by one. Okay, so in order to nums I, we have to check all the numbers and Okay, I got it. This should take index as argument because when we check two numbers, it might depend on other numbers. So in this function, we have to use nums. So so maybe it should take start and end. Yeah, because we needed to find the candidate. Okay, but yeah, target to compare is specified this index. Okay, so this function basically returns true if the number at I is greater than number at j, and also we can use other numbers from start to end. Okay, and the structure is if is larger nums j current max is updated to nums j, and don't forget start to end, don't forget to pass start to end as argument, but at this point the store yeah, I can be used, okay, and because when we think about j, the number at I can be used like this. So for example, in this case, when we look at 432, this one is can be used, and vice versa. When we look at this value, the other one can be used, yeah, as a concatenating value. So the I is included, okay. Yep. And sort partially, so we have to we have to update the number. Oh wait, but current max. Maybe we have to swap here. So the number so we have to find a appropriate index, because correct. And I is fixed. I is fixed here. So that is great. That is correct. Yeah, and the remaining part is implement is larger function. So the target is this, and hmm. Hmm. I think this is not efficient. Hmm. Hmm. 4 3 4 3 2 4. Oh, this is so complicated. I cannot figure out the solution. But I want to solve. Yeah, 43 comes first, obviously, because the third digit is 2. So 43 comes first. And except for 43, which one is largest? So 42, 43, 432, 432, 43. Yeah, this one is largest because when we compare this one and this one, this is edge case. Basically, we can assume 4 follows here, but there is only one element remaining, so that will be 4 3 2 4 3 4 3 2 4 3, then 4 3 2 4 3 4 3 2. Is this so difficult? Isn't it? I cannot figure out, so Mm, 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 I give up. Really? Really? Okay, 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 okay. Times 10. Mm? The maximum number that input can be. So if you multiply each string, but you guarantee much. Ah, it repeats same character 10 times. So this makes sense to me. But it's um Really? So the sorting function always compare two of them. And it seems they are not depend on other values. Really? Oh. Oh, exactly. Makes sense. So take two values and which one should comes first? Which one should come first? Oh. Oh. Okay. Compare function. It takes two arguments. Compare two key. I see. Maybe duplicated. Compare parameter for sorting function like solid and list sort was removed in Python 3. This change was part of a larger effort to simplify the language and unified comparison mechanism. Func tools. Can I implement this? Comp not defined. Oh, this one? Maybe like this. Oh, great. Okay, so the problem here is how to determine the largest number. In other words, we have to compare two of them, so and just decide which one come first. So the sorting algorithm is like this. That means I didn't understand this. Return B should come before A. Yeah. So when we compare two values, in order to know which one should come before is concat them in two ways, and if the second one should come before first one, this function return 1. It means swap. Yeah, the second one should come first. Yeah, this is because all we have to do is to determine which one come first, and this function are applied to all combinations of pairs. So yeah, so we just, it's okay just to compare two of them. So they are not depend on other values, because for other values they are also compared by this function. So we just focus on pairs, and based on this function we can sort it. That's it. So in this case, just compare this pair, one pair, yeah, and there are two possibilities. This one and this one. And the length must be the same, so we don't think about the blank. And yeah, and this one should come first, so this one must come before this one. Yeah. That's always true. Yeah. For this example, we check the all of combinations, and for this comes first, always come first. Okay. This one come first. So yeah, putting one by one. So for remaining part, 4 3 2 4 3 2 4 3 4 3 2 4 3 2 4 3. Oh, this is same. 4 3 2 4 3. Four. And 4 3 2 4 3 2 4 3 2 4 3 2. They are same, so it's fine. And this should be the largest. Makes sense. Okay. I wanted to solve this problem, but I cannot find the solution. Okay, thank you for watching. But recently I got able to think things in English. So yeah, I continue to practice English speaking. Bye.